Okay, so let's do one more example. In the previous video, there's an example of a divergence series and then one that converges absolutely. This is going to be one that converges conditionally. And this is one that we already did most of it on a previous video, but I'm going to go over it again uh, with this in mind. All right, so we discussed what absolute convergence and conditional convergence means in the previous video. So essentially we need to check this out. So this is an alternating series. So we know, first of all, for 1, we have 0 is less than or equal to 1 over n, which is less than or equal to, n plus 1, which is less than or equal to 1 over n for all n. Basically, we have here 1, 1/2, 1/3, 1/4, 1/5, and so forth. So that works. And number 2, we had to check the limit as n approaches infinity of 1 over n, and this equals 0. Right, we got nothing in the numerator. You could use L'Hopital if you wanted to, but you don't have to. It's already in a 1 over n situation, so that's going to equal 0. So by alternating series test, this series converges. So we know it converges. Well, that's the whole thing. Now we need to check the absolute value. So let's do that. But n equals 1 to infinity of the absolute value of -1 to the n plus 1 times the absolute value of 1 over n equals this. Our negative just turns only the positive. It's always 1, and we're left with 1 over n because the n values are strictly positive. And this diverges because it's a p-series. Where p is less than or equal to 1, or equals 1, which is less than or equal to 1, so it diverges. Therefore, our series converges conditionally.